Lowering costs while improving environmental performance is the industry's holy grail. This webcast is entitled New Approaches to Site Access, Minimize Cost, Risk, and Impact, and will provide solid take-home value on how technology can significantly lower operator costs and reduce footprint. This webcast is graciously sponsored by Tensar International Corporation. Hi, I'm Mike Killalea with IADC and drillingcontractor.org. I'll briefly introduce our panelists by name, job title, and company, leaving their full bios for later. Our first speaker is John Bolton, Director of Marketing for Tensar International Corporation. John will set the stage for us. Following John, we'll hear from Keith Brooks, Tensar's Petrochemical Business Development Manager, who will discuss installation and some case histories. Our next speaker is Clark Holmes, Oil and Gas Business Development Manager for Tensar, whose 35 years of oil field experience lend him expertise for E&P applications. Please take a moment during the webcast or afterward to post questions for the panel. While we cannot answer questions in real time, the panelists will prepare responses which will be posted later on this page. We'll shoot you an email when the responses are live. And thanks to those of you who have already submitted questions. We will answer most of them during the webcast. Now let's hear about some non-drilling technology that can enable higher efficiencies in our business. John Bolton has more than 20 years experience in the geosynthetics industry, including design, sales, business development, and marketing. He's published and presented numerous papers on the design and use of geosynthetics and Tensar systems for site development. John is an active member of the Geosynthetic Materials Association Executive Council, the American Rail Engineering and Maintenance of Way Association Committee 1, the Geo Institute, and the American Society of Civil Engineers. He holds a Bachelor of Science degree in Civil Engineering from the Georgia Institute of Technology and a Master's of Business Administration from Georgia State University. John, the floor is yours.
Thank you, Mike. Today's discussion topics are listed here, and for my portion, I'll be covering the top three: site challenges, alternate technology, and the details of working surface solutions. Then I'll pass it to Keith, who will get into the details of installation and case histories, followed by Clark, that's going to give us some practical experience from the field. With that, let's start here. Many of you may be familiar with these types of site conditions: very wet compressible soils, high water tables perhaps, heavy loading conditions, none of which you can control. So the question becomes, what do you do when you get to this spot? How do you handle these challenges? So we'll start here with common site challenges. This picture says it all. When you get to your site, you know exactly where you need to be with your drilling, and you encounter issues like this. Here we see a lot of water content and a very weak subgrade, and you're going to compound the challenge here by putting a heavy load on top of it. So how do we handle this? You also may be in areas where you have high water tables, which also compounds this challenge. Here's some other images that express what we're talking about. These soil conditions, you typically can't stand on it, you can't put your weight on it, and it usually results in heavy rutting, as seen in the bottom right corner picture. How do we handle these? Well, there are conventional ways to handle it, which you all are very familiar with. But today we're going to talk about an alternative technology that will result in these types of images and solutions, where you can drive very heavy loads, whatever's required at your site, on top of these sections and these working surfaces to drive productivity, to decrease the environmental impact, and to really lessen the wear and tear on your equipment. It's just another shot that shows probably a local road to a drilling site that's common. And in all of this, what we do with these solutions, we started and we're deep rooted in the public roadway sector. Our company history is around 30 years in this technology, and so this we will talk and address the partnership between how we take these solutions from the public sector and local roads to you at the drill pad. So what are we talking about? What is the alternative solution? We call it mechanically stabilized layers. And a mechanically stabilized layer is the combination of a triaxial geogrid and aggregate that you're used to working with already at the site. These images on this slide in the right side of the slide show where we're putting the triaxial geogrid in the section, the working surface section. And also, if you look at the image at the bottom left, you see the actual picture of triaxial geogrid and what it does. The grid itself confines and interlocks with the aggregate, thus reducing the aggregate's movement both vertically down deeper into the subgrade and laterally out away from the pressure of the wheel load. That's how ruts develop. If we can prevent the aggregate from moving and arrest that movement with the triaxial geogrid, we're solving the problem. So here I actually have a piece of the triaxial geogrid, and it's important to know that this is just a sample, but it's very lightweight material. It's a polymeric material, and it's produced, just to keep it short, by extruding resin into a sheet and punching holes in the sheet and then drawing the sheet in several directions. And when we draw the sheet in those directions, the polymer chains align and gain strength, and that's how the grid is produced and how it performs so well. Also, it should be mentioned in the picture on the right side of the screen that shows the asphalt layer, we understand that these sites typically do not have asphalt, and that's coming from our roadway technology side. That's why that image has that there. Working surface, traditionally, they do not have asphalt layers. We're going to dive a little bit deeper into the technology. How does the grid work? What do we mean by confinement? There's a tremendous amount of third-party independent research on our grid and our products, and we do that so that we can design with confidence. So what you're seeing here on the left side of the page are 3 images that represent the pressure under a wheel load into the aggregate or into the subgrade through finite element analysis, which is simply looking at the impact of the pressure on grains of soil particles beneath the wheel load. The magnitude of the arrow, the size of the arrow, and the color of the arrow indicate more pressure. So the larger the arrow and the color red or orange indicate areas of high pressure. So notice in the very top image, with no geogrid, the pressure goes nearly vertically down into the subgrade, and that creates the challenges on the site. The second image shows our prior generation BX geogrid and how it relieves a lot of the pressure or spreads that load over a larger area. You can see less large arrows and less red color in that image. Then finally at the bottom you see our high performance new generation Triax geogrid that was developed specifically for this loading condition, and you can see the dissipation of the load and resulting in no large arrows and no red or orange. And what this means to you on the job site is that we're literally cutting thickness out of your aggregate section, typically on the order of about 50%. The diagram on the right actually shows the actual wheel loading in the testing facilities. Here we have the output from a design tool that we use called SpectraPave 4 Pro. And this design tool is used daily, routinely in the roadway business, both public and private sector. So everything from large DOT jobs to private sector jobs. This would be what you could expect to see from Tensar in a design capacity. On the left you see a cross-sectional area of an existing roadway section with thicker sections, thicker layers, and on the right you actually see the enhanced performance which drives a thinner section using triaxial geogrid and a mechanically stabilized layer. There are other tools that we use in our design team. Tensar has a design team that helps support our customers out in the field. You simply provide us with details on your site with geotechnical reports, loading conditions, the equipment that you're using, and we can help with the analysis. PCASE is actually a public tool that was developed by the U.S. Army Corps of Engineers. Stands for Pavement Transportation Computer Assisted Structural Engineering. And it's a modeling tool that can virtually be used to design any load or footprint of any equipment that's out on your site. Here you see some very unique hauling equipment that we've used in the past to create these sections. PCASE, incidentally, is available at no cost on the PCASE website. Likewise, SpectraPave 4 Pro is available on the Tensar website for free download. Now we'll come to some videos that demonstrate this technology further, both through a conceptual visual and then at a real site on how it actually works. Here we have a demonstration video that we call our sandbox demonstration. And the purpose and the intent of this video is to demonstrate bearing capacity and the additional bearing capacity and performance that you can realize with triaxial geogrid. From a practical standpoint, this is for visual purposes only, but we'll follow this video with a video from the job site that shows this bearing capacity performance in action. So what you see here is two boxes. One we will have no triaxial geogrid in, and then the second on the right will have the triaxial geogrid, so that you can see the difference in performance between a control and a section that's been stabilized with triaxial geogrid. To simulate a soft subgrade, we've used memory foam in the base of the boxes, and that's what you see here. Next, we add the aggregate, just like you would in the field, right on top of the compressible or soft subgrade. The grid's added to the box on the right. Next, we add the load. In this case, we're simulating a man walking on a soft subgrade. He moves from the unreinforced control section onto the section with Trax geogrid, and the performance is apparent. Without the geogrid, the box to the right performs just like the control, as expected. I've actually done this with customers in these boxes, and what you feel when you walk on it is just like what you see. Okay, let's take this concept to the job site. What you're seeing now is a pretty heavy hauler on a haul road that's 12 inches thick, 12 inches of aggregate directly on top of triaxial geogrid. Not a lot of movement as the wheels pass. You'll soon see him drive off the end right there, and that is what happens without the stabilization of triax. Very common. We see this all the time with our customers in the projects that we work on. Let's review quickly the benefits of this alternative. First, we've got the cost savings, and what we're talking about there is the reduction of your thickness of your working surface up to 50%. Increased stability. This is delivering more durability and performance out of a section stabilized with triax than with a control section with nothing, conventional methods. And that can help with your workovers. Any site that we need to return to in the future, you don't have the maintenance issues that you would normally think of. Less time. When we're taking aggregate out of the system in the quantities that we've talked about, it really does have impact on the construction schedule, getting to production earlier. Less aggregate. Here's where we talk about environmental stewardship. The magnitude and scope of the jobs that we work on literally save hundreds, if not thousands, of truckloads of aggregate on a given site. And that's important to reduce the carbon footprint and overall environmental stewardship on job sites. Finally, all this put together, we're developing solutions and a design alternative that helps reduce risk. It helps create a stiffer platform, a mechanically stabilized layer that reduces maintenance issues, rutting, wear and tear on your equipment, and speeds up your access to production.
Thank you, John. I learned a lot from that presentation. And by the way, there will be links to P-Case and, of course, to Tensar International on this web page, or webcast page, where you're viewing our webcast. So, John, before we turn it to Keith, I'd like to ask you, what best practices are implemented with new and current roadways?
That's a good question. The best practices, the benefit for this particular market is that we have 3 decades of history in the road design business, both public and private. So with this history in the roadway market, we're bringing that directly into the oil and gas market with proven experience, proven performance, and so there's not a lot of really trial and error at this point. We've vetted all of that, and you're going to hear about other best practices relative to installation, what actually happens on the job site from Keith.
Now that the stage is set, Keith Brooks will talk about installation and case histories, as John indicated. Keith is Petrochemical Business Development Manager for Tensar, based in Cypress, Texas. He joined Tensar in 2010 as Regional Manager in Portland, Oregon, and completed assignments in Portland, Dallas, and now in Cypress. Keith works with petrochemical owners, engineers, and contractors to provide cost-saving solutions for the petrochemical and supporting industries. He's a 1998 civil engineering graduate from Oklahoma State University and is a licensed professional engineer in the state of Texas. Keith, please take it away.
Thank you, Mike, and thank you, John. We're going to move in a little bit and talk about the details of working surface solutions, and in particular the installation sequence. And then we're going to move into a few case histories. When you utilize GeoGrid technology, the product's going to show up on your site typically in truckload quantities on a flatbed truck. You unload the product, you stage it on your job site, then you're ready to install. When you install the GeoGrid, you typically lay it out so that you have an overlap that's predetermined. You'll roll it out a little bit at a time, and then you'll spread aggregate as you're moving forward on your project. There are times when they will roll out an entire roll or even an entire drill pad before they place the aggregate, and that's okay. It's certainly up to the contractor what they choose to do. But typically we find best practice is to roll it out a little bit at a time, put your aggregate down, spread it, and then roll out a little bit more and proceed with your installation. Let's look at a project up in Carrollton, Ohio. This is the Rex Energy Ocel well pad site. This is a finished picture, and we're going to go back and talk a little bit about this job. In this particular job, the owner was very concerned about the durability of this site throughout the harsh winters in Ohio. And they were also concerned with saving initial cost. And so we started this project utilizing a product called TX160. This is an access road to the site. And they needed to make sure that they built a road that would sustain the traffic during construction and then to maintain the well site throughout its life. They then built up the pad, as you can see here, and began the installation of the Tensar GeoGrid. You can see that on this site they decided to roll out the majority of the grid prior to any aggregate placement. Then they came in with their aggregate trucks, back dumped directly on top of the Triax GeoGrid, and then they spread the aggregate and compacted it using small dozers. Now on this project, this is what it looks like in a finished state and in operation. On this site, they reduced the amount of aggregate from 18 inches down to 8 inches. So they cut 10 inches of aggregate out. And the savings to the owner on this project was approximately $250,000. This is a project that I was directly involved with here in the greater Houston area. It's a private pipe manufacturing facility. On this site, we did a P-case analysis, as John talked about earlier, and this is a summary sheet of that P-case analysis. The owner decided to go with a product called TX5 and 18 inches of aggregate. You'll notice that the loading conditions on this site were very high. They were using a Hyster 700H forklift, and that forklift exhibits a load of 150,000 pounds on the front axle. And so being able to bridge that was critical. Additionally, the owner had concerns with maintaining a good solid working surface. When you're carrying pipes throughout one of these yards, if you hit a significant rut, and a significant rut in this application is say 2 to 3 inches, you run the risk of dropping the load of pipe. And you drop a load of pipe, that could easily cost the owner hundreds of thousands of dollars in lost product. So they wanted to make sure that they had a good maintained working surface, which is also critical on drilling sites. So far on this project, we have supplied over 550,000 square yards of GeoGrid. And I'll tell you in a minute why that's important. There's an additional 300,000 square yards that are currently underway, and there's an adjacent site that's slated for early 2015 that would be close to the same size. Now, in this part of Texas, aggregate is not very readily available. And you'll see that the average cost for aggregate is about $30 a ton. I'm going to talk real quick about one element of this project, and that's what they call the tube yard. And this site was about 50 acres, so of the 553,000 square yards, this This consisted of about 250,000 square yards of that site. We saved 8 inches of aggregate versus the unstabilized section. And 8 inches of aggregate over an area that large is equivalent to about 55,555 cubic yards, or right at 100,000 tons. So one of the other things that was critical to this owner was maintaining a good environmental stewardship in the community. They're new to this community, and they wanted to make sure that they didn't come in and cause a lot of disruptions. So just to put things into perspective, 55,555,000 cubic yards equates to somewhere around 4,500 to 5,000 trucks. So 4,500 trucks that they were able to remove from their county road system certainly, prolong the life of those county roads and help the taxpayers there not have to spend additional resources to maintain and repair those roads. So the average cost, like I said, around Houston is around $30. This was a large site, and so for this calculation, we utilized the price of $25 a ton. GeoGrid cost for this site was about $1.90 per square yard, and when you do the math, it was a total savings to the owner just in the tube yard alone, which is about a third of what we provided, just over $2 million. So on this site, we were able to save the owner a significant amount of money. They have a better working surface with less risk, and they maintain an environmental stewardship reputation within the community. Here's a few pictures of this project. You can see these sites are vast open fields. They come in and they stage the GeoGrid just like you saw on the Rex Energy project, where they have multiple rolls. They put them side by side, they maintain the overlap, and they roll it out as they spread the aggregate. One best practice they found on this site was that they actually spread the aggregate across the GeoGrid, and that prevented any kind of waves from forming. They would simply shingle the GeoGrid and then spread the aggregate appropriately. This is what one of their part of their laydown yard looks like post-construction, and you can see they're still building it over on the other side. We've seen this slide before in John's presentation, but this is another local project. This is an NGL fractionation facility in Mount Bellevue, Texas. On this site, they had a lot of unique loads, including what we call an SPMT, which is a self-propelled modular transporter. They were utilizing this to bring in a lot of their heavy equipment, and they needed to make sure that their haul roads were able to sustain the loading from these unique pieces of equipment. On this site, they actually utilize a little bit stiffer product than on the other one, called TX160. And they utilized approximately 300,000 square yards of material. So here's a picture of the installation on this one. Unlike the other photo where the other project where they rolled a little bit of grid out at a time and spread the aggregate, this contractor chose to roll a very large quantity of grid out all at one time. So they rolled it out, and then they brought their aggregate in and spread it appropriately across the site. And to give you some perspective of what this site looks like without the GeoGrid and the aggregate, here's a picture of the entrance to this yard, and you can see the significant rutting that they would experience. And keep in mind that this is just under highway legal loading, and so you can imagine what that would look like if you put an SPMT that can support hundreds of thousands of pounds.
Very informative, Keith. Thanks a lot. Can you give us an idea on, in summary, what kind of aggregate savings you see using GeoGrid?
Yeah, absolutely. It's not uncommon on these sites, depending on the original thickness or the unreinforced thickness, to see savings of 40 to 60% of the aggregate. And if you're in an area where aggregate is not very readily available, where you either have to bring it in on rail or in some cases on the barge, aggregate costs can be substantial. And so if you can save 40, 50, 60% of the aggregate on these sites, it relates to a significant cost savings. And not only a cost savings from the standpoint of financial dollars, but the cost savings of negative publicity from an environmental standpoint.
And that's an excellent point, because that's one of the things we hear, and especially some of the new areas of drilling these days for the shales. People aren't used to our oil field trucks, that they are very critical of how we destroy their local roads. So thank you again, Keith. And folks, this is clearly not traditional oil field site access, but never fear, we have a longtime industry veteran to point out some important advantages. Our next speaker, Clark Holmes, joined Tensar as Oil and Gas Business Development Manager following a 35-year career in the upstream industry. After college, Clark learned the nuts and bolts of engineering, manufacturing, and installing a wide range of drilling and completion equipment. He moved to Bangkok as branch manager and was soon promoted to country manager. that made him the youngest country manager in the company. He was subsequently named area manager and before long became president and director in Southeast Asia. His sterling achievements earned him the promotion to executive vice president at the company's Houston headquarters. There, Clark was charged with revamping the North American business and ensuring streamlined production. Clark, we welcome your remarks, sir.
Thank you, and thank you to my colleagues. My colleagues have done an outstanding job of explaining how the GeoGrid works, and that we've been in the business. We've been in the business a long time. I'd like to speak to a little bit of actual experience using the grid on location. As we know, we've come a long way in a lot of areas in drilling and speeding up the time from the old days of the Kelly now to the top drive, but we've been a little slower in developing the stability from board roads to chemical to what we're discussing today. And we know there were problems with all of those first two. Board roads, my goodness, we all knew we were going to sink out of sight sooner or later, just a matter of time. With chemical stabilization, we had problems with uniformity, we had problems with trenching, water getting underneath, rigs leaning, and forbid, some driller not paying attention and accidentally punching a hole in the casing. And we knew what that, and we don't want to go into that because we know what that costs and what it can lead to. Well, we were looking for solutions, and we really couldn't find it. Our rigs were sinking, our people were sinking, efficiency was down, and we were introduced to the Tensar Triax GeoGrid. Frankly, I said, hey, look, this stuff is plastic. We're putting steel on this. Guys, come on, be real. However, let's give it a shot. Why not? Look where we are now. We're stuck now anyway. We're going to have to drag the rig off location. Well, it worked. And I have to say I was amazed. Amazed so much that after a short retirement, I decided to join the company. What this also, some of my colleagues, some of the points that they may like to know about is that you don't need skilled labor for this. You can be anywhere in the world, even if they don't speak English. It's so easy to install. And instead of having to go for days with chemical or getting way ahead of the game, having to do locations far ahead so the setup time is adequate so it doesn't crack. It may crack anyway if it's not done uniformly, as we know. With Tensar, you can go well by well without all this long planning, all this excess labor. Lay the grid down, in a few hours, you're ready to spud. You're saying, okay, I'm ready to spud. Now, this is plastic. I'm going to run a drill bit through it. Well, most of you are using diamond tip drill bits now anyway, but even if we weren't, our product was designed to be cut. So you just cut right through it with your drill bit. You don't have to be worried. The worst thing that could happen to you in the worst scenario is a small piece of this has to be taken off initially. A small piece of grid, but that's even rare. Very, very rare. Secondly, once we completed, you have a location and a site that has been customized through our engineering department that my colleagues have so aptly demonstrated today. That is for your location, designed for it. The driller doesn't have to, you don't have to worry about your driller paying as much attention. Your rig's not going to lean. Even the old rigs using strong backs, we've set them in that. It's solid, it's stable, it lasts. Let's say, you know, worst case scenario, and you need to get back on that location 5 years from now and close your master valve. Well, with our product, you got a road that we can guarantee you're going to get back there and then be able to close it and shut that well in. Or when it comes to work overtime and you want to get back to the rig, the road's going to be good. It's going to be easy to get in, easy to get out. So it is an excellent installation. It's proven itself already in the oil patch with a multitude of companies. I wish I could name them. Maybe one day we will. But a multitude of companies are now using it, and it is taking off in the oil patch. And this really is the next step down the road. And we'll continue to improve as we go. But right now, there is nothing in the field that I have ever found superior to the Tensar Triax GeoGrid for rig stabilization of soil.
Well, thank you, Clark. You make it sound extremely attractive and point out some real order of magnitude potential savings in safety and in dollars too. So Clark, I heard you mention the cuttability, for lack of a better word, of GeoGrid. As you know, industry's had problems with geosynthetics in the past, at least drilling through geosynthetics. So you're telling me that this product is completely different from that? How can you elaborate?
Completely different. Number one, it was designed for this specifically to be cut, and if necessary, after you cut it, to patch it if you require to, if you need it. So we got ahead of the game. We covered this before we got there because we knew this was a problem. Remember, our company's been around 30 years. So this was an anticipated problem. You have, of course, trenches around all your fuel, your electrical lines. Feel free to trench through it, and you don't have to worry how deep your trench is, because the water is never going to migrate underneath and destabilize it, as it could with other older technologies.
Very interesting. Thank you, Clark. Now let's open the discussion. We've received some great questions from the registrants. I'm curious what else Tensar is doing in the oil and gas industry. Keith, can you elaborate a little bit on that?
Yeah, absolutely. Absolutely. Thank you, Mike. That's a great question. Clark's role with Tensar is he is an upstream business development manager. I typically work in the downstream market. So, some of the case histories and the projects that we showed you today were more in the downstream where we're, using ethane crackers and NGL fractionation plants. So we certainly use it throughout, upstream, midstream, and downstream applications. And additionally, we use it all over the world. I mean, Tensar has manufacturing facilities in several locations throughout the world to service markets like Russia, Brazil, South America, the Middle East, Africa, and Europe. And all of the GeoGrid that we sell here in the United States, we manufacture in Georgia, and so all of our products are domestically made. And that we've found that that's been a very big plus with a lot of our clients in the oil and gas industry.
Certainly, one would infer that there's a certain level of quality there that one might not get out of other locations. So, John, what are some of the load-carrying characteristics and capacities of GeoGrid, and how does that jibe with state and local laws? Can you fill us in on that?
That's a great question, too. Fortunately, we've been in the public sector with roadways for decades, like I mentioned earlier. And so that allows us to have relationships with some of those agencies, very good relationships to help gain acceptance with this technology. So coming at it from that angle, we have a good basis to build on with this market sector. But I would say also that we're challenged nearly daily all over the world as a global company with unique and redefining load conditions, site conditions, all of these things. I'm thinking currently of, say, the oil sands up in Canada where the equipment has gotten so large that it's off the mining charts. The conventional mining charts that are used to design haul roads for mines, the equipment is so large it's off the charts. So we take those challenges internally with our engineering team, and we use things like PCASE to take the technology and apply it to performance and sections that work. So we've not really found a limit to what we can do with this yet. There's certainly different ways that we handle it. It might involve multiple layers of GeoGrid, for instance, to handle larger loads. But we have a tremendous amount of experience, and so I would say the limit that I've seen so far has been defined by the Canadian market with oil sands up there.
Very good. Here's a question from the audience. Gentlemen, so how can we quantify the effect of negative publicity?
Well, I'll take a stab at this, and as we know, that's a difficult question to answer because it depends on what the negativity is. Again, and along with your relationships, we know our industry is based on relationships. We all know that. And we develop them by working together and learning to trust each other. So, what are they? Depends on what it is. If it's tragic and results in the loss of a well, probably not a recovery. But that's rare. That's rare. One of the things about our grid is it's going to help prevent you from getting into those situations. As we stated earlier, you're going to have a customized location, and it's going to be the same all over, unlike others. It's going to have the same strengths. It's going to be uniform. It's rarely that you're going to get into a negative situation if the proper information is provided to us so we can engineer it for you, if necessary, properly. And we're not above, and this needs to be said, we're looking for long-term relationships. If we should run into a case where we don't, for some reason, do not think our grid will work, we're going to tell you. We're looking long-term, not short-term. So we don't want to get into that. And if we have to get into it, we'll deal with it. We've got sufficient engineering, we believe, to get us out of just about everything except a massive, massive failure, which probably wouldn't be a GeoGrid problem to begin with.
Yeah, Clark, you bring up a good point, and you know it really does depend on the severity of the negative publicity. I mean, we've seen in this industry everything from loss of life to you know, drill rigs falling over to simply, you know, beating up county roads. And you know, I think, you know, when you look at a Tensar solution, our goal is to reduce your risk. And so if we can reduce that risk of negative publicity by, you know, taking less trucks off of, you know, taking trucks off of the county road system, so that you do less damage to the county road, that's going to help, and it's going to reduce your exposure there. If we can give you a better pad site, so that, you know, if you have to pull a rig off of a well site, that you can do that without destroying the rig and causing hundreds of thousands of dollars of damage. And so our goal in this technology is to reduce your risk, and, you know, and thus reduce your negative publicity.
Thanks. Okay, so another question, Clark. What about skidding rigs for multiple wells on a site?
We know that's becoming more and more common as people are putting more and more wells on location, on sites, making larger pads, and requiring more grid. By utilizing the Tri-Ax, it's going to help you skid. How? Well, if you don't have it, and you happen to have bad weather when it's time to skid, when you start moving over and shifting the weight, what's going to happen to your rig? It's going to lean or it's going to dig in. With Tri-Ax grid down and installed properly, you will skid smoothly and easily and fast.
Thank you, Clark. Wow, that's pretty impressive for some of our shale activities these days. So that's about all the time we have. Gentlemen, do you have any final comments you'd care to make?
Mike, I'd just like to reiterate, thank you for the opportunity to share this technology with the webcast audience. I would suggest that from this point, the audience apply what you've learned with these concepts and this technology. We're more than happy to provide proposals to your conventional approaches on all your sites, or we can even, if you have an in-house team of engineers that would like to learn more about the steps to do these designs, we'd be more than happy to teach what we know to your team. And one other thing we'd like to mention is our test drive program for new users, like some folks on the webinar. What you've seen today, if you want to try it on your job site, just get in touch with us, anyone on the panel, and we can have a roll of Tri-Ax on your job site for you to try, risk-free at no cost.
Thank you, John, and thank you, Clark and Keith, for your very useful presentations, and thanks very much to Tensar International for sponsoring this webcast. I ask the audience, please submit any questions you wish through the webcast page. We'll post the answers as promptly as possible and notify you all via an email. This virtual panel discussion will be posted here indefinitely, so feel free to return, and please invite your colleagues to check it out as well. On behalf of drillingcontractor.org, thanks for tuning into this event. Stay safe and keep turning to the right. I'm Mike Kilalia, and we'll see you next time.